Okay, we are recording. So let's do, we did in the last class, we did exercise number 10, I think so. Yeah, let's do exercise number 11. So it's a giving an IP address, so this IP address, on a subnet mask, this subnet mask that have been configured in a host. You are asked to find the number of subnet bits. So what will be the number of subnet bits in this case? So for that, we need to define first what is the class of the IP address. It's class A, class B, or class C? It's class C, no? Remember, class A is between the first byte have been between 0 and 127. Class B, 128 and 191. Class C, 192 and 223. So this is class C. What is the default mask for class C? /25. And this is what? This net mask is what? Is a /27, no? This is a /27. 224 is 11100000. It have 3 1. So 24 1 here plus another 3 1 is 27. So the net mask by default is 4/24, no? So how many bits did I borrow when I go from 4/24 to 4/27? 3 bits. So 3 bits. We borrow 3 bits on the host part to make them subnet bits. Okay, how many subnet can I create in total? If I borrow 3 bits, it will be 8, which is 2 to the power of 3, no? And 2 to the power of 3 is 8. Okay, how many host bits are left? Five bits, correct. So how many IP address in total I will have in each subnet? In each subnet I will have how many IP address in total? 2 to the 5. 2 to the power of 5. And 2 to the power of 5 is 32. Okay. What will be the network address of this subnet? Of the subnet, this specifies a specific subnet. Okay, I put this IP address in a computer with this subnet mask. This computer belongs to which subnet? So if you look at this, you can infer the magic number. What will be the magic number? 256 minus 224, which is 32. What does it mean? That when we create a subnet, we go by step of 32. So what are the possible subnets? 192, 168, 200, 0. This is a subnet. What is another possible subnet? Since we go by step of 32, 0 plus 32 is 32. What will be another possible subnet? 32 plus 32 is 64. What will be another possible subnet? 64 plus 32 will be 96. What will be another possible subnet? So 96 plus 32, 128. What will be another possible subnet? Look, here we say there are 8 subnets. Up to now, we have 5. What will be another possible subnet? So 128 plus 32 will be 160. What will be another possible subnet? 160 plus 32 will be 192. What will be the last subnet? 192 plus 32 will be 224. So this IP address belongs to which subnet? Does it belong to the first subnet? What is the range of IP address in the first subnet? From .0 to what? From .0 to .31, isn't it? The second subnet go from .32 to what? To .63. The third subnet go from .64 to .95. These subnets go from .96 to .127. These subnets go from .128 to .159. This one go from .160 to .191. These subnets go from .192 to 223. And this last subnet go from .224 to 255. So this IP address is in which of all these subnets? Is it in the first subnet? So the first subnet go from .0 to .31. Is .139 between .0 and .31? No. So it is not in the first subnet. Is it in the second subnet? No. So here it is in one of the subnet. Which one it will be? Yes, it will be this one, because this one go from .128 to .159. So it will be in this one. So that's correct. It is in this one. So this is one way to see it. What will be another way to answer this question? So you can do the bitwise AND between the IP address and the subnet mask. So let's do it. Let me open Paint and let's do the bitwise AND. So the initial IP address is 192.168.200.139. So if I want to know to which network this IP address belongs, I have to be the bitwise one with the subnet mask. So I have to do the bitwise one with 255.255.255.224. So what will be the result of the first byte? When you bitwise AND with 255, what will happen? You keep the value. So it will be 192. This will be 168. You keep the value. This will be 200. So the only one that is a little more complex is the last one. I better put it in binary to see what will be the result. So let's put it in binary. What is 139? It's 128 plus 11. What is 11? 8 plus 2 plus 1. So 139 will be 1. 128 is there. 64 is not there. 32 is not there. 16 is not there. 8 is there. 4 is not there. 2 is there. 1 is there. That will be that in binary, no? So if I do 139 bitwise on 224, I will have to do 1 0 0 0 1 0 1 1 bitwise on 224. In 224 we have 3 1. So 1 on 0 is 0. 1 on 0 is 0. 0 on 0 is 0. 1 on 0 is 0. 0 on 0 is 0. 0 on 1 is 0. 0 on 1 is 0. And 1 on 1 is 1. What is that? 128. So here we have 128. So look at this result. This result is exactly what we put there. We put that it belonged to the network 192, 168, 200, 128. So we found the same result by doing different methods. So this IP address belongs to this network. Okay, what will be the broadcast address of this network? So remember, we go by step of 32. So 128 plus 32 will be what? 160. 160 is where the next network starts. So this one will end where? Exactly. It will end in .159. So what is the last valid IP address? It will be one IP address before the broadcast address. And what is the first valid IP address? One IP address after the network address. If I ask you how many valid IP address we have in this network, what will be the answer? 30. Remember, if the total number of IP address is 32, we lose this IP address, which is the first IP address. We lose the last IP address. So 32 minus 2 is 30. By the way, if you look at the number of IP address that we have between these two numbers, we have 30 IP address. Okay? How can I do it with a calculator to check that we have 30 IP address? Guide me here. How can I do it? I can do 158 minus 129 plus 1. So here we have 30 IP address. Okay, if I ask you between 7 and 13, both inclusive, how many integer we have? You have to do 13 minus 7 plus 1. Plus 1, no, not plus 2, plus 1. So we have 7 number between 7 and 13. 7, 8, 9, 10, 11, 12, 13. Give you 7. So between P and Q, you have Q minus P plus 1. So between these two IP addresses, we have 158 minus 129 plus 1 IP addresses. And this gives us 30, of course. Okay, same exercise, but with different value. So, what is the IP address? Is it class A, class B, or class C? C, of course, no? Because the first byte is between 192 and 223. So what is the default mask of a class C? Let me write it here. The default mask is /24, which will be 255, 255, 2550. This is the default mask. Now we have created subnet. So we are not using the default mask. What is the mask that we are using? It is there. What is that in Dotted decimal notation is for us what? In 248, how many one we have? We have 5 1. Isn't it? In 248. What is 48? 248 is 1 1 1 1 1 0 0 0. So we have 5 1. If we have 5 1, how many 1 we have in this mask? 8 plus 8 plus 8 plus 5, isn't it? Every 255 is 8 bits. So it will be what? /29, exactly. So we went from a /24 to a /29. So how many bits did we borrow? 5. 5 bits. Okay. If you borrow 5 bits, how many subnetwork you can create? Correct. 32 subnetworks. 2 to the power of 5. Okay, 2 to the power of 5 is 32. Okay, how many bits are left for the host part? Three bits, correct. Okay. So here they ask you what will be the number, the total number of IP addresses per subnet. Of course, 2 to the power of 3. Okay, 2 to the power of number of bits that I have in the host part, which is 8 IP addresses in total. Remember that we lose 2 IP addresses, no? So if they ask you number of valid IP addresses, it will be only 6. Or number of host IP addresses, or number of usable IP addresses. Okay, what is the network address for this subnet? So 2 ways to do it. First way will be what? We know that the IP address will be, if we go by step of 8, here we have to go by step of 8, no? Because the network have 8 bytes, 8 IP addresses, sorry. We can compute the magic number. Let's compute the magic number. The magic number will say go by step of 8 in the 4th byte. So the magic number will be what? 256 minus 248. And 256 minus 248 is 8, which means that we have to go by step of 8. Here we are also say that we have to go by step of 8. If we go by step of 8, it means that the 4th byte have to be what? If it's a network, if it's a subnetwork, it have to be a multiple of 8. So what is the multiple of 8 that is closer to 180? (22) is the multiple of 8 that is closer to 180.
I'm at 8 times 22. 178.
178. Okay, let's verify that 178 is a multiple of 8. So let me put, okay, the scientific calculator is 178 divided by 8. You say 178? No, 178 is a multiple of 8. 176 divided by 8 is a multiple of 8. So it's 176. What does that mean? The network will be 176/29. Okay, the last byte have to be a multiple of 8 because we go by step of 8. So if you go by step of 8, what are the possibilities? Let me write down all the possibilities. It can end up in .0. It can end in .8. So the one that end in .0 have IP address that go from .0 to .7. Is this IP address is between .0 and .7? No. So I try the other one, .8. After .8, I will have what? .16. After .16, I will have what? I just write the end because otherwise it's too long. .24. After .24, I have what? .32. After .32, you have what? .40. Then .48. Then .56. Then .64. Then plus 8 will give me what? .72, isn't it? Then .80. Then .88. Then .96. Then .104. You see, those are the possibility. So of course, if I continue, I have to continue a lot to reach that. So .112. What will be the next one? 128. 134, isn't it? 142. Yes or no? Let's see. 14 is correct. Yeah, .120 is missing. You are right. 128 plus 8, it will be 134. No, it will not be 134. Plus 8, it will be 136, no? Plus 8, it will be what? 144. Plus 8, it will be what? 152, isn't it? Plus 8, it will be 160. The next one will be what? 168. Plus 8, it will be 176. Plus 8, it will be what? 184, no? .184. So for example, I'm not writing all of them, but if I take the network that end in .128, it's go from 128 to what? To 135. Is this IP address between 128, this IP address is between 128 and 135? No, it is not. So in which range it is there? Obviously, it is here. Because this one go from 176 to 183, isn't it? I put all the multiple of 8 here for you. So it belongs to this network. Okay? So another way to do it is, let's go to binary. And let's do it in binary. So we have, as an initial IP address, we have 192, 135, 250, 180. And we have to bitwise on this with what? with 255, 255, 255, 248. So what will be the first byte? 192, I don't change it. The second byte, because I bitwise on with 255, I don't change it neither, 135. The next byte, I don't change it neither, because I bitwise with 255. The only difficult one is the last byte. So for the last byte, I'm going to convert to binary. So what is 180? Is 128 plus what? Plus 53, isn't it? And 53 is what? 32 plus 21, isn't it? And 21 is what? 16 plus 4 plus 1. Do you agree with that? So 128 is there, 64 is not there, 32 is there, 16 is there, 8 is not there, 4 is there, 2 is not there, 1 is there. So that's the binary of 180. Let me just verify it because I don't want to continue with a mistake. So I go to the programmer calculator, I put 180. There is no what? Oh, at the end? Yeah, you're right. It cannot have a 1. So it has to be B4. So B4. So I don't know why I say plus 1 here. It has to be plus 4, and that's it. Okay, so we don't have this here. We just have this. Let's try it again. So it's 128 plus, oh yeah, 128 plus 52, isn't it? Yeah, and 52 is 32 plus 20, and 20 is 16 plus 4. So it gives us that. So in binary, let me write 180 is 1 0 1 1 0 1 0 0. And 248 is 5 1. 5 1 inside. When you bitwise AND, 0 0 0 0 1 1 0 1. So it is what? 128, 64 is not there, plus 32, plus 16. 138 plus 32 will be what? 160. And 160 plus 16, 176. So this one is 176. This is exactly what we wrote here. Okay, so you can do it bitwise AND, or you can just think what is the multiple of 8 that is closer to 180. Okay, so what will be the broadcast address? So look at, I am in this network. The next network starts in 184. So this network have to end where? One IP address before 184. What is one IP address before 184? 183. So that will be 192, 135, 250. Oh, by the way, did we put 255 at one point? Here it was 250. Nobody say anything. Okay, here it was 250. So it's 250 here. Let me make this modification here. 250. So it will be 250. So 250. One IP address before 185 is 183. Okay? So what is the first valid IP address? One IP address before one IP address after 176 will be what? 177. What is the last valid IP address? One IP address before 183 will be 182. Of course, look, if you have a total of 8 IP addresses, between these two IP addresses, how many you should have? 6. You lose 2. So between 182 and 177, we need 6 IP addresses. Let's verify that. 182 minus 177 plus 1 have to be 6. As you can see, we have 6 IP addresses. Okay, you can count them to see that we have 6, but we have 6 valid IP addresses, no? So remember, I put all those numbers to show you that the network address have to be a multiple of 8. If we go by step of 8, if you start in 0 and you go by step of 8, of course, you will have a multiple of 8. Okay. There are many exercises. Please look at them. If you have anyone that you specific that you want to resolve, you let me know. I'm going to go to other exercises. We are going to do now subnetting with variable length subnet mask, which means that we are going to create subnetting of different size. Okay, first exercise here. A company has 3 departments: Department A, Department B, and Department C. The requirement for valid IP addresses or usable IP addresses or host IP addresses is the following. Department A needs 120 host IP addresses. Department B needs 48 host IP addresses. And Department C needs 22 host IP addresses. The company has the following block of IP addresses. So this is the block that the company has. Using fixed length subnet mask, what does it mean? You are going to create subnet of the same size. Okay? Design a network addressing scheme that will fulfill the requirement, which is the minimum number of hosts per subnet. Complete the following table. Okay, so let's see that. In this network that have the company, what is the total number of IP addresses that I have? In this network, how many IP addresses I have? 256, which is 2 to the power of 8, because the host part is 8 bits. So 2 to the power of 8 is 256. So we have 2 to the power of 8, which is 256 IP addresses in total, no? Now, for Department A, what is the minimum requirement? Can I give them exactly 120 IP addresses? So what should I give them? 128. Correct. For Department B, I have to give them 64. I cannot give them 48. It has to be a power of 2. For Department C, 32. So let's count 128 for A plus 64 for B plus 32. Oh, sorry. If we are using subnet of the same size, what will be the size, the common size? I have to use a common size between A, B, and C. Because we are using here, they say, you are using subnet of the same size. So what will be the common size to fulfill the requirement of the 3 departments? 128. I will have to give all of them 128. So I will give A 128, but I will also give B 128 because they have to be of the same size. And I also will going to give C 128. So at the end, how many IP address I need? 3 times 128. What is 3 times 128? So 3 times 128, 384 IP addresses. 384 IP addresses I need. Do I have them? No. How many IP addresses I have? I have 256. So can I resolve the problem if I use subnet of the same size? No, I cannot resolve it because I don't have enough IP addresses. So it will not work if you use fixed length subnet mask. There is no solution with fixed length subnet mask. If all the subnets have the same size, I don't have enough IP addresses to resolve the problem. Now, look at what they say. Then answer the same question, but this time using variable length subnet mask. So if I use variable length subnet mask, what does it mean? That I can do network of different size. So there is no problem that A receive 128 IP addresses, B receive 64, and C receive 32. There is no problem. They can receive network of different size because I'm using variable length subnet mask. So what will be my total requirement in IP addresses? It will be 128 plus 64 plus 32. What is that? 224 IP addresses. Do I have them? Yes. I have in total 256, so there is no problem with VLSM. If I do subnetting of different size, there is no problem. It's why we move from FLSM to VLSM, because VLSM gives me more flexibility. I do subnetwork as small as they can. I don't do all the subnetwork of the same size, which spare a lot of IP addresses. Okay, so now they ask you to fill the table. What will you give to A? What will you give to B? What will you give to C? So what will be the network of A? So what will be the mask for A? If I want to give it 128 IP addresses, what will be the net mask? If the net mask is /24, how many IP addresses I have in this network? /256. So can the net mask be /24? For A? No, it's too big. I have to give to A something smaller. So what will be smaller than 4/24? 4/25. If I give to A a 4/25, how many IP address I give to A? 128, correct. It will be 2 to the power of 7, because How many host bits we have? 32 minus 25. And 32 minus 25 is 7. So it have to be a /25. Okay, so this means that I have to go by step of 128, isn't it? If the subnet have 128 IP address, I have to go by step of 128. So what will be the network that I give to A? 200.770/25. Okay? So this network will end where? What will be the broadcast address? If it will be .127 at the end, exactly, because it have 128 IP address. So it will be 200.770/127, correct. So the last usable IP address, or the last valid, will be 126, and the first valid will be what? 1. Now, let's do B. What is the size of the network for B? Can it be /24? If I give to B a /24, how many IP address I'm giving B? $256. Too much. I want to give B 64. So can it be /24? No. If I give it a /25, how many IP address I'm giving to B? 128. This is what I want to give to B? No. Too big. What I want to give to B is 64. So it cannot be a /25. So it has to be smaller than the /25. Let's try a /26. If it's a /26, which is smaller, how many IP address I will be giving to B? 64. So B have to be a /26. We have 64 IP addresses there. 32 minus 26 is what? 6. 2 to the power of 6, 64. So in this network, a network /26, we will have 64 IP addresses. If we have 64 IP addresses, that means what? I have to go by step of what? Of 64, isn't it? I have to go by step of 64. So look, the network of B should start where? 128, correct. Because the network of A ends in 127. So if the network of A ends in 127, the network of B have to start in 128. So 200.770/128. By the way, if you remember, the magic number of A was 128. So 0 plus 128 give me 128. Now the magic number of B is 64. So 128 plus 64 will give me what? Which means that C will start in 192. This is what it means. Okay, let's keep doing B. So of course, the first valid IP address is one IP address after this one. So it will be 129. What is the broadcast address? How do I get the broadcast address? So if this one starts in 192, the previous network, which is the network of B, have to end in 191. And of course, the last valid IP address, which is one IP address before 191, will be 190. Okay, now let's do C. C need 32 IP address. Can I give to C a /24? too big. A /24 have 256 IP addresses. I want to give C just 32 IP addresses. So can I give C a /25? Too big. It's 128 IP addresses. Can I give it a /26? Too big. It's 64 IP addresses. Can I give it a /27? Yes. This is what I have to give it. 32 minus 27 is 5. 2 to the power of 5 is 32. So here we have 32 IP addresses, which means that if we have a fourth network, let's call it D, where is this going to start? We don't have network D, but let's suppose that we have an additional network. Let me insert. Let's say that we have D. D should start where? So since C have 32 IP addresses, we go by step of 32. So 192 plus 32 will be what? 224. So if D exists, doesn't exist, no? It should start in 24. If D starts in 224, where C is going to end? 223, which is one IP address before where D start. So what will be the last usable? One IP address before 223 will be 222. Where is the first usable? One IP address after 192 will be 193. Okay? Let me remove this. I just added it to explain you. Okay, so this is the information of each network. So a way to verify that everything is okay. Verify that C have 32 IP addresses. So how do I verify that we have 32 IP addresses here? If I do 223 minus 192 plus 1, it have to be 33. So let's do it. 223 minus 192 plus 1, 32 in total. You see? Between this one and this one, we have 32. Now, between these two we need 30. Because we lose 2. We lose this one and we lose this one. It have to be 30. So if you do 222 minus 193 plus 1, it have to be 30. Isn't it? For example, if you do 127 minus 0 plus 1, this will be 128 because A have a total of 128 IP addresses. If you do 191 minus 128 plus 1, it have to be 128. It have to be 64, sorry, because B have 64 IP addresses, no? Did you get it? Okay, let's do exercise 2. A company has 4 departments, A, B, C, and D. Let me put all in the same page. So a company has 4 departments, A, B, C, and D. The requirement of usable IP addresses is the following. Department A needs 28 usable IP addresses. Department B needs 22. Department C needs 100. And Department D needs 17. If we are going to create subnet of the same size, what will be the smallest subnet that fulfill the requirement of all the 4 departments. Let's say that we are going to make subnet of the same size. What will be the smallest subnet in size that will fulfill the requirement of all the departments? 128, of course. Because if I want to fulfill the need of C, I cannot give C less than 128. So if all the subnets are of the same size, I have to give all of them 128. So I satisfy the need of A, I satisfy the need of B, the need of C, and the need of D if I do 128. If I do something smaller, let's say that I do 64. A will be happy, B will be happy, C will be happy, but A, B, and D will be happy. But C will not be happy because C is asking for 100. And I'm going to give it 64, it will not be happy. So to make everybody happy, I have to give 128. Okay? So look, if the network that I have is this network, how many IP addresses I have in this network? I have 2 to the power of 8, which is exactly 256 IP addresses. So in total, I have 250 IP addresses. If I give A 128, give B, give C, give D 128, how many IP addresses I will need? I will need 512. Do I have 512? No. So there is no solution with fixed length subnet mask. You understand that? There is no way, if I use the same size for all the subnets, to resolve this problem. So what should I do? I'm going to do subnet with different sizes. So how much IP address should I give to A? 32 IP addresses in total, no? How much should I give to B? 32 also. So they are happy. How much I should give to C? 128. How much I should give to D? 32 also. Now, if I do that, do I have enough IP addresses? Let's count. I will need 32 plus 32 plus 128 plus 32. This gives me what? 224, no? Let's check it. So it's 32 times 3, 32 times 3 plus 128, 224 IP addresses I will need. Do I have them? Yes, I have 256, so there is no problem for 224. I will still have some that I can use for if the company grow. Okay, that I will keep just in case that the company grow. I will still have 32 IP addresses that are left and that I'm not going to use. So let's do this problem. So there is something that is very important when you solve this problem. You have to go from the higher requirement to the lower requirement. Of the 4 network, which one have the higher requirement? C. So you have to process first C. Then who have the highest requirement? Okay, the other are going to have 32. So the other, there is no order. You can do them as you want, but I'm going to do A, B, D. Okay? A, B, and D need 32 IP addresses. So if I do A first, B first, D first, it's not a problem because they have the same requirement. But C, I must start with C. I have to go from the highest requirement to the lowest requirement when I give IP addresses. Okay, so C need 120 IP addresses. Can I give it a /24? If I give it a /24, how many IP addresses I'm giving to C? 256, too big. So /24 is not the correct subnet mask for the network of C. So what is smaller than a /24? /25. If I give a /25, how many IP addresses? 128. This is exactly what I want to give to C. So what will be the network of C? Correct, 30.10.2.0. Since I give 128 IP addresses to C, where is the network of A have to start? 128. 0 plus 128 is 128. Now I'm going to give 32 IP address to A. The network of B have to start where? $160, correct. Why 160? 128 plus 32, because I'm going to give 32 IP addresses to A. Now I'm going to give 32 IP addresses to B. So the network of D have to start where? 192, correct. Now let's suppose that we have one more network. We don't have it, but I'm just going to make it easy. Let's suppose that we have another network. This network will start where? 224, why? Because the size of the network of D is 32. So 192 plus 32 will be 225. Okay? Now, should I put here /24? /27, why? Because we want to give 32 IP addresses. So 32 minus 27 give us 5. 2 to the power 5, 32 IP addresses. So if I want to give 32 IP addresses, it have to be a /27. This guy also need a /27 in department B. In department D, they also need a /27. So they get 32 IP addresses, okay? Okay, what will be the broadcast address here in C? 127, it will be one IP address before the next network. So the next network starts in 128. So this one will end in 127. What should I put here? Like the broadcast address of A. So B starts in 160. If B started 160, this one must end in 159. What should I put here for the broadcast address of network B? 191, because the next network starts in 192. What should I put for the broadcast address of network D? 223, because if there were an additional network, it will start in 224. We don't have this additional network. Let me suppress that. Okay, so this is very easy to fill, no? For example, let's fill the last valid IP address. So one IP address before 127 is what? 126. One IP address before 159 is 158. One IP address before 191 is 190. One IP address before 223 is 222. Now, I want to do the first valid. One IP address after 0 is 1. One IP address after 128 is 129. One IP address after 160, 161. And one IP address after 192, 193. So if we want to verify that here we have 32 IP addresses, what we should do? For example, in network D, I want to verify that we have 32 IP addresses. What should I do? So I should do 223 minus 192 plus 1. 223 minus 192 plus 1. Tell me you have a total of 32 IP addresses. Now, if I want to verify that the number of valid IP addresses is 30, I should do what? 222 minus 193 plus 1. So 222 minus 193 plus 1. Tell me I have 30 valid IP addresses, okay? Any question about this? Okay, let's see the next exercise. Exercise 3. Let me put it in the same page. Okay, so a company has 5 departments, A, B, C, D, and E. Also in the network of the company, there are 2 point-to-point links. The requirement of usable IP addresses is the following. Okay, so 12 usable IP addresses for A, 50 for B, 27 for C, 10 for D, 5 for E. If I use FLSM, what will be the size of the net of the subnet that I have to choose? 64. Now the exercise say you use VLSM. I can make subnet of different size. How many IP address should I give to A? 16 IP addresses in total for A, correct. How many should I give to B? 64. How many should I give to C? 32 IP addresses in total. How many should I give to D? How many to D? 16, no? How many IP address should I give to E? 8. And we have 2 point-to-point. How many IP addresses for each point-to-point? Correct. 4 IP addresses for each point-to-point network. P2P for point-to-point network. Okay? So, my initial network is this one. How many IP addresses I have in this one? In total? 256 IP addresses. Let's verify if we have enough to resolve the problem. So I need 16 for A plus 64 for B plus 32 for C plus 16 for D plus 8 for E plus 4 for the first point-to-point, plus 4 for the second point-to-point, okay? Because we have two point-to-point network. So in total, let's compute that with the calculator to see how much we need. So we need 16 plus 64 plus 32 plus 16 plus 8 plus 4 plus 4. We need a total of 144 IP addresses. Do we have them? Yes or no? Yes, we have them. We have more than that. So we will have IP addresses that we will not be using. Spare IP addresses just in case that the company increases its size. Okay, so let's do an addressing scheme. So remember, we have to process from the biggest one to the smallest one. So which one I should process first? B. I should do B. After doing B, which one I have to do? C, correct. After doing C, which one I have to do? A and D. Any order is okay. For A and D, I can do A first, D second, or D first and A second. I will do AD. After that, what should I do? E, and after that, the 2 point-to-point. So I have to do them from the biggest one to the smallest one. Remember that. So what will be the network of B? 192, 168, 100, 0, / what? 26, correct. Because if it's a / 26, I am giving it 64 IP addresses. So if B have 64 IP addresses, C will start where? 0 plus 64 is 64. C will start in 64. Okay, if C have 32 IP addresses, A will start where? Huh? It will start where? 96. Why 96? 64 plus 32. Okay. Now, if A have 16 IP addresses, D will start where? 112, correct. Why 112? 96 IP addresses where I start in A, plus the 16 that have A. 96 plus 16 will give me 112. If D have 16 IP addresses, E will start where? (128). Why 128? 112 plus 16. Okay? If E have 8 IP addresses, the first point-to-point network will start where? 136. If the first point-to-point network have 4 IP addresses, the second point-to-point network will start where? 140. Let's say that we have another network. We don't have it. So I just add that to help you. This network that does not exist, if this one has 4 IP addresses, the next will start where? 144. Okay, because this one has 4 IP addresses. So it will have 140, 141, 142, and 143. So this one will start in 144. Okay? So what is the size here? / what? So I want C need 32 IP addresses. So it should be a / what? /27, of course, no? A / 27 of 32 IP addresses. Why? 32 minus 27 is 5. 2 to the power 5 is 32. Now I want A to have 16 IP addresses. So it will be a / what? 28, correct. I want D to have also 16 IP addresses. It will be a / 28 also, okay? Remember, 32 minus 28 is 4. 2 to the power 4, 16. So D have 16 IP addresses. Okay, if E have 8 IP addresses, it should be a / what? If you need 8 IP addresses, how much host bit you need? 3, because 2 to the power of 3 is 8. So if you have 3 host bits, 32 minus 3 is 29. So it's a / 29. Okay, the point-to-point network have 4 IP addresses. They have to be what? / 30, correct. / 30, okay? So let's put the broadcast address. If the network C start in 64, network B end where? In 63, correct. If network A start in 96, network C have to end where? 95. So if network D started 112, network A have to end in 111. So here for network D, the broadcast address is going to be 127. For network E, the broadcast address is going to be 135. For network, the first point-to-point network, the broadcast address is going to be 143. The second point-to-point network, the broadcast address is going to be, sorry, here it's not 143, it's 139, no? 139, sorry. And here it's going to be 143, okay? So I removed this, that was there to help you. We don't have this network, in fact. So delete the entire row. Okay, so now that we have this information, the last valid is just one IP address before the broadcast address. So 63 will be a 62, 95 will be a 94, 111 will be 110, 127 will be 126, 135 will be 134, 139 will be 138, 143 will be 142. And here, one IP address after 0 will be 1, after 64 will be 65, after 96 will be 97, after 112 will be 111, 113, sorry. After 128 will be 129. After 136 will be 137. And after 140 will be 141. Okay? So look, for example, these point-to-point network have 4 IP addresses. 136, 137, 138, and 139. So this is the first IP address, I lose it. This is the last IP address, I lose it. So the valid are between 137 and 138. And between 137 and 138, we just have 2 IP addresses. So this point-to-point have 2 usable IP addresses. This is what we need, 2 usable IP addresses. So in total, we need 4, no? Okay. Will you be able to do this one? Exercise 4, or should we go on it? Maybe we should go on it. What do you think? Okay, so look, department A have 10, need 10 IP addresses. How many I should give to A? 16. Okay, department B need 4 usable. How much I give it? 8. Okay, because if I give it 4, what will happen? How many usable I give it? It will be only 2. So if I give it 8 in total, 8 minus 2, I'm giving it 6 usable. They need 4 usable. 500, big department. What should I give them? I have 12. Correct. 100, what should I give them? 128. 200, what should I give them? 256. And we have 3 point-to-point network. For each point-to-point network, I need to give IP addresses. So let's see if there is a solution. Let's see if we have enough IP addresses. Let me put everything in the same page. So look at my original network is 19.6.16.0/22. How many IP addresses are there in total? How many IP addresses? 2 to the power of 10. Okay, which is 32 minus 22. 2 to the power of 10, which is what? 1024 IP addresses I have in my original network. How much I need? Let's count them. 16 for A, plus 8 for B, plus 512 for C, plus 128 for D, plus 256 for E, plus 4, plus 4, plus 4. Okay, because we have 3 point-to-point. So let's compute that. Let me see if I can put that in the calculator directly. With Control V, yeah, it did work. So, did it work? Oh, there is a scientific calculator. Control V. There is a missing, okay. Here it is. How many IP addresses I need in total? 932. Do I have them? Yes. So it means that I can resolve the problem. I have enough IP addresses to satisfy everybody. Who is the first network I should work with of all this network? C, the biggest one. After doing C, I should do what? E. After doing E, I should do what? D. After doing D, I should do what? A. After doing A, I will go to B. And then each point-to-point network. We have 3 point-to-point. So C start here and have 512 IP addresses. So where is E going to start? If you do 0 plus 512, you will have to put a 512 here. Can I put a 512 here? No. 512 is what? 2 times 256. So 512 2 times 256. It means what? How should I change the third byte? 18, exactly. And this one, 0, is 2 times 256 plus 0. So the 2 go with the third byte, and the 0 go with the fourth byte. Okay? Let's do another exercise. If I have here 514, no, let's put 516. 516 is what? 2 times 256 plus 4, isn't it? So what should I do? Instead of 16 to 56, 18, 4, isn't it? Do you agree? So since it was 512, we add 2 here, and here we add 0. So this is where E will start. Now E have a size of 256. So I should put 19 plus 6 times 19, 6, 12, 256. Can I put 256 here? No. What is 256? 1 times 256 plus 0. So the 1 will add here to 13. And the 0, 0 plus 0 will be 0. Isn't it? We will do the net math after. Okay, A, D have 128 IP addresses. So A will start where? So 0 plus 128 will be 128. Okay, A have 16 IP addresses. So B will start where? So 128 plus 16 will be what? 144. Okay, B have 8 IP addresses, so the first point-to-point should start where? So 144 plus 8. $152, no? Okay. The first point-to-point has 4 IP addresses. So the second point-to-point will start where? So 152 plus 4 is 156. Okay, the second point-to-point have 4 IP addresses. So 156 plus 4, 160. And let's say that we have an additional network that does not exist. So this network will start where? So 160 plus 4, because the last point-to-point are 4 IP address, will be 164. So what will be the net mask of C? So C need 512 IP addresses. Yeah.
You go from 19.6.16 down to 19.6.12.
19.
It should be 18.
Yeah.
It should be 19.
This one?
Yes.
From the first one to the second one?
Yeah.
So C have 512 IP address. So let me write it here. So I should go to 19, 6, 16, 0 plus 512 is 512. I should go to that. Can I write that? No. It's like if I ask you, can you write 879 minutes? No, you cannot write 879 minutes. So if you have to write 879 minutes, what are you going to write? So 79 is 60 plus 19. So it will be 9 o'clock, 19 minutes. This is the correct rate to write 8 o'clock and 79 minutes. We don't write 8 o'clock and 79 minutes. The same thing. We don't write IP addresses like that. So what is this 512? This 512 is 2 times 256 plus 0. So these 2 will apply to the third byte. And this 0 will apply to the fourth byte. So which means that I have to add to 16. Oh, I saw your comment. We did a mistake here. We start in 16. We have to go to 18. 19. 19, 19, 19, 19, 19, 19. Okay. Yeah, just say we make a mistake, that's it. Okay, when we add up 2, we didn't add up 2. So 16 plus 2 is 18. Okay, and 18 plus 1 is 19. Okay, so what is the size of this network? Thank you for spotting that, no? So C must have 512 IP addresses. So what will be the size of /what? /23, correct. A /23 have 512 IP addresses. You do 32 minus 23, it gives you 9. 2 to the power of 9 is 512. Okay, E need 256 IP addresses. What will be the the subnet mask? 24. D need 128 IP addresses. It will be what? 25, correct. A needs 16 IP addresses. It will be what? 28, correct. 28 of 16 IP addresses. B need 8 IP addresses. It will be what? 29, no? On the point-to-point, 30, 30, 30. Okay? So that is easy to fill. Let's fill it. What will be the broadcast address here? So one IP address before this IP address. will be what? Exactly, 17.255. Okay? So this network have all the 16 and all the 17. By having all the 16, we have 256 IP addresses. And by having all the 17s, we have another 256. So 256 plus 256, in total we have 512, which is what we need for C. We need 512. So it's why it's covered the 16 and the 17. So it's gonna have 512. Okay, what is one IP address before this one? One IP address before 19.0. 18.255. What is one IP address before this one? 19.6, 19, 127. No? Here we will have what? Before 144, we have 143, isn't it? Here we'll have what? Before 152, we have 151. Here we will have what? Before 156, we have 155. Here we have what? Before 160, we'll have 159. If here we have what? Before 164, we have 163. And of course, this line that I added to help you, I'm going to remove it. So this is it. So the rest is very easy. You just fill it. Okay, the last usable IP address is one IP address before the broadcast address. There is a tool that we can use. I will show you this tool next time. So let me save this exercise, and next time when we come back, we will ask the tools to give us all these numbers that we have here, and it will give us all these numbers. Okay? Okay, remember that homework number 1 is there. I'm going to put the due date now because you already have all the knowledge to finish with homework number 1. Okay, so work on it. Okay, I see you next week.